The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good afternoon, good evening, wherever you are in different parts of the world. We have another exciting, very relevant, very important webinar today. Thank you all for joining. This is a webinar on PBL, Sustainable Development Goals and Engineering Education, Promises and Challenges. And the webinar sponsored by IFEES, GEDC, and IUCEE. We have with us our distinguished speaker from Denmark, and just to you have seen her detailed abstract and bio, but just to quickly introduce her, Dr. Aida Guerra is Vice Director of Aalborg Center for PBL Engineering Science and Sustainability under the auspices of the UNESCO, and Associate Professor within the field of problem-based, project-based, project organized learning and engineering education for sustainable development at the Department of Planning at Aalborg University, Denmark. She is trained in biology and geology education, science education, PBL and sustainability, and holds a PhD degree in PBL and education for sustainable development in science and engineering education. And so with that, a brief introduction. I will not take up any more of your time. I will get her directly to speak with you, and I'm going to make you a presenter, Aida, and as you can see her on the screen. So you can just click show my screen, Aida, and you're ready to go.
Yes. So good afternoon. Thank you for the introduction, and thank you for the organizers to invite me in and actually organizing this webinars, because given the current situation at worldwide level, it's actually very important to keep the community in touch and sharing experience, knowledge beyond face-to-face meetings and physical spaces and conference and so on. So thank you very much. So I was already briefly introduced as my position at Aalborg University and at Aalborg UNESCO Center for Problem-Based Learning, Engineering, Science and Sustainability. And I actually started working at Aalborg UNESCO Centers in the beginning of 2011, precisely doing my PhD and working in these areas that I'm going to talk about, that I'm going to share my knowledge, my experience, the work we have been doing in the center, empirical work from some years back, but also more recently, and how we are evolving. And how we see this as promises and challenges for what actually the future, that is ahead of us, right? So I'll just turn off my camera now, and I will move to the presentation. So the title of this presentation is Problem-Based Learning, PBL, Sustainable Development Goals. And from this point on, I will be referring to it as SDGs. It's more easy. And engineering education, promises and challenges. And as the title says, I'm bringing three themes together. So how the three together hold promises, but also have challenges, right? And to some might be actually quite straightforward, but I would like to take the opportunity to go deep and actually raise the discussion as well in the community. So why is this not changing? Yes. Yes, no, it's just taking more. So the focus of this webinar, we start with a little bit of reflection on the role of technology and engineering education to contribute for the SDGs. And this is one of the promises, actually. The SDGs is one of the promises for our future, to hold a secure and sustainable future. Then we move focus more in education for sustainable development. In specifically the engineering education for sustainable development and the principles and its principles of educating for sustainable development, and what are the relations with PBL. And this is, we can say, promise one. And then from this promise one, we move to promise two, and then start actually looking into the associated challenges as well. So we look into PBL models, and PBL has been in practice around the world since the 60s. Now it's emerging more models due to the needs of the professional challenges, but also societal challenges like the sustainable development challenges. And what are the difference between these models from a conceptual level and how they are a promise? And from this, they link with actually we are observing in practice, namely variation of problems and projects. And this is just a connection point I'm making, because early May, there was a webinar given by Annette Kolmus, my research leader and my colleague, and my other colleague, Luke, focus on actually variation of problems and projects. So here I'll just make a connection. This is the promise number 3. And then I would actually close up the webinar with a reflection of further challenges and how to overcome them. And I think that could actually open for discussion afterwards and for reflection among the community. So as promised, I will start with this picture that I'm sure that a lot of you already have seen it. A lot of you have heard about them, and they are out since 2015. The United Nations Goals for Sustainable Development. And this is a promise. This is the promise that we need to act to secure a sustainable future for the future generations, and I include myself. I have more years to come, hopefully, but also for my kids. They are also a future generation, so they come with a promise. And there is a worldwide recognition since the Paris Accord, where countries actually recognize this, and sustainable development is actually now part of world nations' strategies. And as researchers, we can see it in research, a call for fundings, applications, that this needs to be embedded. It needs to be addressed in that. So that's a promise. But how do we do this? That is the major challenge. As researchers, how do we actually address, how do we make this general global framework for action contextual? Here, if we look into the 16 core areas that define the Sustainable Development Goals, they are related with technology as well. Technology here plays a role as part of the solution. So our engineers have a responsibility of being able to contribute for these solutions as well. And these 16 core areas were defined based on what was not done with the millennium, or what was not achieved with the millennium for Sustainable Development Goals, but also in an international worldwide consultation survey. And that's what generated. So this is actually global. And as a 17th goal is actually the partnerships. And here the technology like financial, like capacity building comes explicitly stated as a mean to strengthen the partnerships among different stakeholders, but also in the different SDG goals to fulfill and to actually act for them. So here is a brief introduction to the Sustainable Development Goals, the SDGs, and the one I will focus particularly is number 4, the quality of education. And that's actually our business, as to speak, is actually where we act, and we have a responsibility as professionals, but also as citizens, right? We are educators. And quality of education, what is the aim is to ensure inclusive, equitable, quality education and promote lifelong learning opportunities for all. And then if we go deep, if we dig deeper, then we can start actually questioning what does it mean quality of education in engineering education context? What does it mean quality of education in liberal arts? So this we need to conceptualize what is quality of education in this context. And actually in the context of engineering education, and this been in the discourse for some time, is actually we have to address the fast innovational and this fast evolved profession where our students go to perform. this global profession there is engineering profession, right? So this is actually what we can start thinking about quality of education. What kind of qualification profile do they need? And what kind of competences do they need to actually be engineers to perform and act in a global and changing world? And if we go back to 2004, we have this vision, engineering vision 2020, I'm sorry, for the National Science Foundation and the Academy of Engineering from US, that already start stating these challenges for an engineering profession. So quality of education is actually institutions are able to provide and create learning opportunities where students can actually develop the competences, the knowledge needed to actually act as a professional, an engineering professional. And in here, we go a step further. They also need to be able to do it for sustainable development. We need to equip all learners, and here there's no distinguish, but specifically we focus in engineering learners, adults or undergraduates or even STEM education in low levels of school, like elementary school or high school. We need to equip them with an understanding of sustainable development, education for sustainable development, the knowledge, skills, and competencies needed. And of course, there's a need for training. So how do we actually achieve this? There's a promise here, but we can actually start thinking in terms of challenges already, right? So we start looking into the key competences. I use here the two most recent references, but the competences for engineering education for sustainable development, or in general for education for sustainability or sustainable development, these key competences or the competences have been in literature since the 2000-2001, and they all kind of align and point out to the same group of competencies: systems thinking, critical thinking, strategic thinking. And if we take education for sustainable development and we go, for example, for Industry 4.0 or the new employable qualification that our engineers need, this is not very far away, actually. Critical thinking need comes for sometimes now, even in the accreditation standard. So this is a need to address. Integrated problem solving, collaboration. This is also something we have been talking and hearing for some years now about problem solving skills, the need for problem solving skills. This is a little bit beyond that. This is actually related with systems thinking and critical thinking and strategy, because this includes the identification of problems in the real life. So what is the problem here? Who has the problem? What are the contextual elements and systems, social, environmental, cultural systems here that affect and defines the problem and has an impact in the solution? So this problem, we can actually refer to complex problem solving. So it's much more than just solving. And of course, due to that complexity, we need to have collaboration. We need to have multidisciplinary, interdisciplinary teams that are able to collaborate, that are able to build common language platforms, so they can actually move into the same direction. So this is what we call key competences, and three more can join in, and this is much more at an individual level. And we are talking about anticipatory, normative, and self-awareness competencies. And I'll start by briefly just refer self-awareness. As an individual, I need to be aware, I need to have the competence to see, to understand the values I hold as a citizen, as a professional, and what contributions can I give as a professional and as a citizen to my local community to achieve sustainability, to address the sustainable development goals. So this self-awareness is very important and is very related with critical thinking, reflection, but also in the situation that our students need to be confronted with these positions. And then, of course, that moves into the normative. Then it's the self with the others. So what others, what norms and values others hold, what principles, what views of sustainability. And no, this can be changed, and this has also an impact. The anticipatory, the last one, is related with the capability of students to anticipate, to foresee that there are consequences. Things are interrelated. So it's not one problem, one solution, but it's the possible problem defined in these circumstances for the best solution that works under these circumstances. And this, of course, is related with this flexible and changing aspects as well that is related to the profession. So sustainable problems are complex, and they require the systems thinking, and students need to be aware of different aspects: solving, collaborative, strategic, reflection, critical thinking, but also the values and the norms that are in place. And if we look, okay, the norms and the values, what makes me an engineer? What is the role of engineer? What is the role of my profession in this bigger picture, in this society, in this company? There's where the questions start. And they, to some extent, they have this question when they get in, and it's related with identity as well. So it's much more than just know and do, but it's also about being an engineer. And we have studies for some years now, and the topic of engineering identity, it's not new. But we have to say now an engineer identity for, and not engineer identity as a single thing, or a single identity, as a professional identity. So it's becoming stretched to integrate other aspects as well. So when we see these competencies and we read about these competencies, then we have to think, okay, what kind of learning environment and principles are needed to actually develop these competencies? Without surprise, we actually have this contextual, collaborative, transformative learning, where students are actually confronted with their values, how they see the world and how they see the profession, and change and learning. A learning process is actually a change process as well, right? But also experiential. So they actually take, they are active, they are involved, they are experienced, and it's led by their own experiences as well. So it's exemplary, social constructivist, and cognitive. So we look into this more innovative and learning theories that explain the way we learn and the better way to learn, right? I'm not going into depth but this kind of start pointing to what kind of environment do we need, and that's what we have in our right side, right? We're calling for an interdisciplinary learning environment, systems oriented, where actually students are not closing their own disciplinary boundaries, but they experience other learning environments where they can collaborate interdisciplinarity from other and stakeholders, other students, and so on. So it's also process oriented. So there is a reflection on the process, why things are they are, and what are the consequences, what are the decisions made, and so on. So there is a process aspect that needs to be focused on and reflect on, but also the problem orientation, the empower, reflective, and critical, the creative and innovative aspects into the learning environment. And here, if we look into the SDGs and the 16 core areas, plus the goal 17 as the partnership, and we see the problems from north to south, east to west, global problems, sustainability problems are different at the local level. So here the creative and innovative learning environment actually has a contextual aspect that is innovation for that context, for that in solving that problem. So by summing up these learning principles, we start thinking, okay, how do we relate with PBL? And how can PBL be a promise for this? Well, from a learning perspective, and this we go back to 2009 to Kolmus, from a learning principles perspective, if we define PBL from a learning principles, we can actually see that problem-based learning holds principles that are aligned or common to the ESD principles. So we have here a win-win situation, right? So we have problem orientation or problem-based. It can be project organized or case organized, contextual learning, experience-based, relation between theory and practice. So students actually implement and work on practice and in real context, right, to solve the problems, interdisciplinary learning, exemplary learning, this reflection on why we make the decisions, what is the problem, why is this a problem, why things function this way, did not function this way, what could be the actions for future, what to do in the next project problem solving approach. All this meta learning reflection also takes place. And then of course the social component, that is the participant directed, that is focused on the participants and is also collaborative, team-based. Right? So from these principles we can say, okay, here is the promised one. Problem-based learning principles align with the education for sustainability principles, what is required from a learning environment. So the competences, we have here a map, a roadmap, some indications of how we can actually achieve the key competences. And then we actually look into the different PBL models and practices, also from literature, and we see there are different possibilities, including Barrow states that there is an infinite possibilities of PBL practices, actually, if we combine the different elements, the knowledge, the learning objectives, the problem scenarios, the duration, and so on. We actually have a multitude. And now that PBL is emerging more and more and gaining popularity, we even see more this diversity of practice in PBL, because it's also contextual. So it's also how the institution develops its own model, its own practice. And what we see here in the first column and the second column is we can say that this is more oriented to the traditional engineering education, right? Focus on know the concepts, the terminology, the procedures, and know how to do, having the technical skills, having the right technical skills to provide the technical solution. So this is very much the focus. There are other examples, there are other models and practices that are also here, like the PBL for interdisciplinarity, that is a combination of both. So we start moving into a more disciplinary learning environment, or the PBL transdisciplinary learning, that we have a reconstruction of knowledge from different disciplines. And here we have we can also see that the problem scenario is increasing in complexity in variables. So we have here a tendency, but what the traditional focus is in engineering education, it remains independently of PBL or not PBL, the main focus is still on the disciplinary development and focus, disciplinary technocratic approach to problems. So they are still close in their disciplinary silos with this technocratic approach to problems, that it's oversimplifying so it can be solved. And these contextual elements are lost. So 2014, we actually start doing a map study, and back then we had one faculty and the study programs were managed by schools, and we had 3 schools. And the mapping was, taking sustainable development indicators, and this time there was no SDGs, so it was the Global Report Index that companies use to report their environmental and sustainable development practices. And we use those indicators to actually try to map the sustainability elements or presence in the engineering curricula at Aalborg University. And the results were at the formal level, the learning outcomes, there's not much sustainability integrate in them. This project was actually financed for the faculty. So this was a point of departure to actually put the eye and look into the situation that we have at our university. So the School of Architecture and Design, where we have more design-oriented architecture, urban planning, environmental management, energy planning, where we have this more soft, as to say, or non-classic engineering programs, they actually have a very high percentage of sustainability mentioned in this program. But this comes without surprise. It's the environmental related problem, like environmental engineering and everything, are more related to this. It's on the school. But when we move to the classical and more core technical engineers, then we can see that there's no explicit, or that this at this stage in 2014, there was very little learning objectives with sustainability explicit in it. Okay, so we talked with managers, we talked with leaders, we talked with the staff, and they all agree we had the structure. We have projects that students choose. We have projects that students have freedom, a degree, ownership, where they can actually choose. And also teachers have ownership over their courses. So we actually went to practice and see. Before that, we actually map also what kind of sustainability is emphasized. And we see that sustainability is synonymous of environmental sustainability. And up to this day, this is still the view. So if it is sustainability, it has to be related to environment. So finance and social is very much neglected. So we have here a conceptual point that needs to be worked. And in 2019, we actually look into students' projects and we screen student projects, and we still have the same perspective into sustainability. So at the bottom level, we actually found different things. So even the percentage was very low. We found some examples, not many, I must say, but we found there examples of staff that are motivated and are engaged in integrating sustainability in their teaching. And we can see full programs, but I already mentioned those programs. We can see full semesters with project and courses related with sustainability embedded into it, and courses that have sustainability also embedded in it. And here in the picture is the example of working with green ICT. So this was the school that had less explicit learning objectives with sustainability aspects in. And we actually categorize these types of problems as sustainability is everything we do. The other category that emerged was sustainability is a part of what we do. And here we have sustainability as part of a course. So normally as an introduction, and here we have actually the example of the windmill. So in the structure and wind loads course, they have an introduction of sustainability of renewable energies and why they're going to study. But it was that was just the introduction, and then it was technical. And then we have some project themes. That sustainability theme comes coupled with a technical or discipline theme. And I'm going to show an example in some, just a few slides ahead. So this is what we saw in 2014. And recently, we actually conduct a study, a colleague of mine, Virginie Servant-Miklos, it was a qualitative longitudinal study that involved students, and she wanted to know how the awareness of sustainability issues evolve throughout the course of their studies, how students have this development. And it was a very interesting study because she could observe that the 4 categories emerged from this study, but also the students actually develop an awareness from no awareness at all or little to a basic awareness with advanced domain specific. So they want to relate their discipline with sustainability issues. So they want to know how they can contribute with. So we have here a change, we have here a shift, at least at the student level. And this is also because they've been confronted with sustainability discourse and media, and how this is, okay, what can we do in our projects? And they find possibilities also to work and engage in activities that relates with this as well. So this is actually a very interesting output recently from a study we did. So if we look into the PBL models and we say, okay, yes, there is a promise that we can move away from this two first columns, this more technocratic approach that is focused only in develop the professional skills or knowledge and content ready to use. Just a side note, PBL emerged from practice. So that's one of fundamentals of PBL, right? And now we actually can look into this landscape and conceptualize and formulate the assumption that maybe it's possible to educate for the profession, focus on developing in the identity where they get in, and they need to have this professional and engineering field identity, but start also embedding and educating for sustainability and for sustainable development. So we have an integration, so we have also a building identity aspect into it, where sustainability becomes part of it. And this is not an easy task, and of course there's challenges, because we have to change institutional culture, we have to change an institutional practice, we have to change curriculum structures, we have to train and everything, we have to engage people. But it's a beginning. And this actually comes for the promise, number 3, that is this variation in problems. We need to have, and projects, we actually have to have a balance between the type of projects and the type of projects and the learning objectives. So if we want to develop a more disciplinary focus, more disciplinary skills, more disciplinary knowledge, that is, the discipline that is the learning objective in one semester, in one course, then we can have narrow problems, disciplinary problems that are more structured, that are more closed. And there's also a student that a teacher has a different role into it. But we can also balance that with more open and ill-structured projects, innovation project, unsolved situations, sustainability problems as well. So we move into another direction where actually the contextual elements are very important in the type of problem we define, and how the students also, we as the students define, and how they also solve it. So from this variation in PBL, the problems and the projects, this interplay, we can actually see a possibility. Now I focus on this more open and ill-structured problems, and we can look into how we engage our students in problem design. And by problem design, I mean problem identification, analysis, and formulation. And here I show you a concept, a framework where of what we actually practice and bring sustainability into this semester project themes. This is, so we can start with a subject theme. And a subject theme, it can be programming, it can be wind loads, it can be renewable energy, it can be municipality, heat or water grid, whatever. It's a technical theme. And within this technical theme, there is a sustainability theme related into it. And this sustainability, we just don't throw it as like sustainability, and then we have students drown it, right? We also need to narrow, because such a theme within civil engineer, mechanical engineer can be a lot of things. The same goes for sustainability. So we need to start, small and narrow, but broad enough, so where actually students can pick. By giving these themes coupled, we actually pull students to know about sustainability. to know about the sustainability theme we bring forward, relate with actually the disciplinary theme, and go out into the real world and find places where they can actually contribute with. And that can be a nursery home, that could be an elementary school, that can be the municipality, this can be the power plant, it doesn't matter. So the students go out and find the problems. This is potential problems. This is not yet defined problems. To become a defined problems, they actually need to learn about sustainability. They have to relate this in depth with the context. Okay, who has the problem? What kind of technologies are used? Why is this a problem? So they kind of analyze and argue for the relevance. And then when the problem is formulated, we have three components into it. We have the sustainability embedded, we have the context, and we have the technical solution. So this all come as interdisciplinary decision-making, reflection, argumentation, and so on. So I think now it's easy to link with these key competences in the beginning, because we have some systems here being tackled as well. And here, if we have this first part of the limiting, where we get the final problem statement, then our formulation, they actually move into the solving process, and that's more purely technical. And once they have the solution, they have to contextualize the solution or the results. And then they go back and say, okay, what are the limitations? What are the impacts? Where are the consequences? What are the future scenarios? And then also assess the learning outcomes, relate with the learning outcomes. So here we can have actually a problem-based approach where we have an open problem theme as point of departure, where problem needs to be defined, and we call it design, and then we have a solving process. So we have here an integrated problem approach. And here I show you now one example, from first year bachelor students, mediology second semester, media technology, and the theme was designing from both sides of the screen. So it has related with designing for mobile phones. So it's something that the user actually sees. It's one side of the screen, and the other side of the screen is the programming component. So they have to design from both sides, right? They have to do the programming, and then they have the app or the program they develop. That's what the user sees. And the theme was sustainable lifestyle through exercise. And here we actually kind of get away from the typical environmental view of sustainability. And this is the activities when students went through by conceptualizing, interviewing, observing, go to the places. In this case, was specifically to a rehabilitation center and everything. So existing solutions, what apps are out there to the aim they want. The problem formulation is what you can actually read. And it's actually quite long. It's a development project. The problem, how can a mobile phone support rehabilitation with daily objects, right hemisphere brain damage patients with the age between 15 and 25. There's a lot of elements here in this problem formulation, but you have a target group, you have a context, and you have a technology. And all these elements, they actually argue for. Why right hemisphere brain damage? They argue for why right hemisphere. They also argue why between 15 and 25, when the first intuition was, let's go for strokes above 65%, 65 years old. That was only 5% of the Danish population. So 15 to 25% is actually people that are still in a learning process. They are still in a growing and development process. And they are people that can be integrated into society. And most of this type of brain damages is actually due to cycle accidents. So they change their view completely by actually going into the context, by talking with physiotherapists, by looking into the places, by talking with patients and everything. And even the color of the design, they figured out it has an impact on these patients. Some colors have a more positive, more motivating effect than others. So all of these decisions were informed by knowledge that is nothing to do with programming. So this is an example. And of course, when they finished, they went through, contextualize the solution. So another example, and this is just briefly, is the mega projects. This is more recent. It's also focused on the SDGs as in collaboration with local external partners, with the local municipality. They bring in challenges where students have to formulate a problem so they can contribute to a solution. And this is actually the bigger structure, and this was already talked a few weeks ago, so I'm not going into in detail. But again, we have here the focus on interdisciplinarity. How can we actually develop interdisciplinarity as a competence by crossing more technical oriented fields with more humanitarian, financial, economic, social science oriented fields? So here we are bringing together different students working in different problems that they have to collaborate across teams so they can answer to the mega project or to the challenge that is the mega project. So to finalize, and I'm already beyond time, just two last slides as a reflection. First, what are the promises? What are the challenges to integrate, to address, to make the SDGs and education for sustainable development a part of the engineering education, a part of the engineer profession in the way we educate the engineers. So here is more for multidisciplinary, interdisciplinary collaboration, allow co-creation, involvement with external partners and stakeholders. And there are examples out there. There are examples if we go to humanitarian engineering, Engineers Without Borders, we can find this element, right? So, but we have to make it accessible for all and part of the formal education. But then we also run into challenges. And one of the challenges is actually this paradigm shift. We are going through a paradigm shift in engineering education. We need to build technical expertise. Our students need deep technical knowledge and skills, but they also need strong values and mindset to address sustainable development as part of their professional practice. So these two should come together. So the complex problems also require that we look into education in a different way. And this is one of the biggest challenges, I would say. And then we need more flexible curriculum, more possibilities for individual learning paths. But how do we actually do this? How do we can create this flexible curriculum? So this is some outputs, and then we actually have to start to think of what is needed to strengthen these promises, and by that start addressing and overcome these challenges. And the first actually more variation of problems and projects that we can actually balance this disciplinary education with a more education for sustainable development, balance this technical and this contextual education. So we can actually meet both that is needed, integrate, make progressive, transformative and contextual learning for engineering profession. And this integrated means that we need to integrate sustainability and sustainable development within the engineering curriculum, and this should be progressive, and we should focus more on contextual learning and transform, bringing this transformative aspects into it. And so we can also create flexible and adaptable minds. Allocation of resources and reward systems. And this has come for any change process. We always need to allocate resources because we need to create new structures. We need to create new infrastructures or rebuild old ones or adjust old ones. And one is actually the revision of curriculums, for example, that we have to make explicit learning objectives. We need to embed sustainability into it. And of course, we need to train staff and students for sustainability and the SDGs. And here we need to focus on the discipline and then broaden up, go across disciplines. Because they need to, the students, and that's what I've been observing recently, the students need to know their identity as an engineer, as a professional identity. And from that, they then are clear and ready to navigate across disciplines and know what they actually can contribute for. And that's it. There, I just have a last slide about the references I've been using throughout the presentation. And thank you very much for your attention.
Thank you.
And I hope this now leads to discussions and reflections, further discussions and reflections. Thank you.
Thank you so much. Thank you so much, Ida. We have a few people that I pulled out into the panelist section. Maybe
yes.
You may or may not have comments, but let's see. Roger Hadcraft from Australia, Sam Mukasa from the US, John Tarakan, JP Mosen, LC, and Manivanan. Maybe some of you might have comments. I'll start with Roger. Do you want to unmute yourself, Roger? Do you have any comments?
Yes. Thanks, Ida. That was really terrific, and I really liked the slide that set out those kind of five phases or 5 ways that PBL can be implemented, from the very technically focused to the very broad focus, which is your mega projects, of course. But I want to pick up something that you just got to at the end, which is this idea of how every student engages in this process, and how you might help every student to think about their own personal learning journey. And I'm wondering if you've got a little bit more to say about that in terms of how you might do that.
I think there's more research needed for that. And that's where I started with that, because what we have seen now, and I'm in a project now actually looking into the resources and students support they need for the SDGs in their own field. And by talking with them, they do not have the space in the curriculum to explore and go after what they actually feel motivated about. They are not, and I'm talking about a curriculum that is project problem based and project organized, half of the semester. And at this moment, there's a group of students, they are happy with the status quo, they go and they choose from the project catalog and they run the project. But then there are other students, they are not, they want more. They want to see what they can do outside, how they can make a difference, how they, it's like stretching your experience as a student to see how far you can go. And not limited yourself to the boundaries of the technical that are imposed to you. Like if a staff comes with a project proposal, they choose that project proposal. They want to be, for example, in workshops. Some students took that initiative to organize workshops where students can create project proposals with staff. That's individual. Because then they go for what they find interesting, that they could explore, they want to learn. And at the same time, they have the staff trying to limit, in the sense that that's too broad, that's out of the curriculum. You need to focus on building these technical foundations first. So the supervision here has another aspect into it. It's the way that students create the project proposal. They come forward with a proposal, but the staff make sure that it's still, meeting the learning outcomes. That's an example of this individual learning could be explored more. And this students initiatives actually.
Okay, great.
Okay, thank you.
Let's have a comment from Elsie, and then we'll go to Sam Mukasa.
Thank you. But a marvelous presentation, and very encouraging, especially to see the contrast between the research on awareness of sustainability as in 2014 as opposed to today, awareness and interest among the students. You know, I'm in the business community, the challenge is parallel, which is to migrate the sense of opportunity or problem from simply environmental sustainability, i.e. with nature, into the larger context of viability or well-being for nature, humanity, and commerce to thrive together. It's a very similar movement, and I think that now here I am in New York, and every night for the past week or more, we have civil unrest, and most of those people out there are young people. It's generational, and what we're and this is a marvelous inflection point. And there you are, you know, with that's who your constituents are.
Yes.
And what we found in business is that generationally, employees are way ahead of the managers, are way ahead of the companies in terms of their values and their sense of urgency about embracing a larger system identity. And I would imagine that in the universities, it may be the same. So we're all kind of playing catch up. And what we're discovering is that the juice is in letting the folks lead who are closer to the action, like the younger generation, like your students. So to have them be shaping agendas in context, as you gave that example of the designing from both sides of the screen, when they went out there and engaged with the users, allowing those who are in touch with the real experience to define the problem and opportunity. So those are just observations, but I do have a question for you. And I'm wondering, since here you are in academia addressing this question, and it's not just about skills, it's about identity and mindsets. We're doing the same thing in the business community and in business academia, and I'm wondering if there's not an opportunity to engage cross-disciplinary at that level, so that we can accelerate each other's learning.
That's a very, very interesting question.
Think about it, okay?
and that's a very good one. And recently I had a meeting with a Canadian colleague that is also working with this, and I think it's possible, and I think we should go to this, what you just referenced, but this paradigm shift. And I don't know if I'm actually referring to your question, but please put me on track if I'm getting a little bit away, because I'm always back to this paradigm shift. And I'm from biology, and I learn about these paradigm shifts. You know, you have, when you discover the cell, you have a revolution in biology. That's the, you know, the core of the research focus of biology. And in physics was the Einstein theories and so on, right? So and then all the research around it, it's to elaborate and strengthen this paradigm to know more about. For in the cell, it's about DNA, it's about replicating DNA. Even now with COVID, that's our basic knowledge to actually be able to test, to understand the behavior, mutations, and so on, right? So that's the core. And I think here in engineering, and I now I broaden up and say in education, we are in this paradigm shift, in the sense that if we talk about professional identity, we talk about professional identity for the SDGs. And if we focus in sustainable motivation studies in one specific field, I think we need to talk with motivation for. And I think this also links with your comments, that we have the front runners lead the way, because they are already engaged. We don't need to control them. We don't need to be afraid that they will not learn, because I think they will, and I think they are capable of it. And I think that from this initial stage that they need to actually have a clear...
We need to move on, Ida. A few more questions. We need to move on.
Okay, so basically it's this, that we need to think about this paradigm, and the studies we are doing now and developing now needs to be within this mind paradigm shift that is for something, and it's not just to understand how it's done in one specific field.
Thank you, Ida. Thank you, Elsie. Question from the audience is about, does Aalborg have a co-op program for the students to work with the industry?
Sorry, can you just reformulate again?
A co-op program where students go and work in industry for some time during the year?
They have projects that are actually provided by the students. There are different types of collaboration with industry, actually. We have industry as just informants, or we have industry as a case where they go there and use it as a case, or we have actually master theses that are completely done in industry. And even industry comes with projects where they actually want students to develop the state of the art. So if they want to carry out in the industry as development projects, they can continue to it. So there's different approaches, yes.
Sam, do you have any comments? Sam Mukasa?
Yes, I do. Well, thank you very much for that wonderful presentation. It's delightful to see that sustainability concepts are being adopted in engineering and science. My observation, I suppose, is that ultimately what we want to do is to have a positive impact on society in general. And often you'll find that decision makers, if you take the US Congress, for example, there are very few engineers and very few scientists, and yet these are the people who are going to make decisions about environmental sustainability and so on. So my question is, does your university is your university attempting to adopt some of these concepts in those fields where many of the decisions originate? This would be people who study policy, people who study business, people who study political science. So science, social sciences and humanities.
I would say that's more with the mega projects, because there are students from social sciences involved in these mega projects as solving a problem. But we also have, I think you touched upon also this science dissemination and science, translating the research and innovation language into the policymakers, right? So there are an impact. So in one hand, mega projects, we have students working on this project with external stakeholders and engineering students as well. So it's across faculties. And on the other hand is that we also have activities and we have programs that there's a strong involvement with external stakeholders, including municipalities and so on. And there's now a movement of this citizen science, where is this using citizens in the co-creation of research, but it's also this a need to train researchers to be able to communicate that research. That should be as part of the upskilling of researchers in academia as well. So from European Commission, there's a movement and there's a concern on that. So the policy makers can actually have input from researchers and engineers into it, even if they are not engineers. But you're right.
Thank you, everybody. I hate to stop this fantastic conversation and running out of time here. We also have a large number of questions which probably more detailed, need more detailed answers. So what I'm going to do is coordinate the collection of all the questions that have been raised by the people from the audience. So more than 200 people here and about 20 questions there. So I'll arrange that to be sent to you, Ida. Maybe if there's something there that you might want to keep in touch or respond to, that would be greatly appreciated. I have just one quick question, and before we close, and thank you on behalf of IFEES and GEDC. Are there some, since you talked about sustainability throughout the curriculum from first year, second year, third year, fourth year, Can you give us some advice on how to structure a general course on introducing students to sustainability starting in first year course on introduction to sustainability? There's something out there that that we can look into so that we can get that started in the first year and then they can build on it?
We are doing some research now, and I'm doing some research now, is actually looking into the students' perspective. And I honestly think that the integration of sustainability, it should be progressive. So you start by raising awareness in the beginning. So it can be seminars, it can be workshops or something, because in the first year they have an overload of information. They are moving for a new context of study to the university. They are starting a new education area that is specialized. There are a lot of things going on. And if we bring on sustainability because it's complex, it's interdisciplinary. So if we bring on the heavy stuff, I think it's too much for them. And I can see how my students struggle with this design from both streams. They are from first year. And I think they do an amazing job. And then that should be progressive, because once they actually are strong in their identity, when they are strong in their technical, then we should actually challenge them to get out of their comfort zone and bring some more complexity into it. Fantastic. So I think it should be progressive. Yes.
Thank you so much. Thank you so much. Very insightful comments, and I really appreciate this on behalf of IFEES, GEDC, and IUCEE. I really want to thank you taking the time, and for the audience, and for the excellent discussion with the panelists. And I apologize for those of you whose questions I could not bring up, but we will follow up. Thank you, and everybody stay safe and stay happy. Thank you.
Thank you for having me. Thank you.